All right, welcome back. So let's find the derivative of the next example here. We're given a function of natural exponential function raised to the power of 6y cubed plus 4. And we're asked to find the derivative of r in respect to y. So the way we're going to do this is by thinking about um, the exponential rule, but also thinking about the chain rule, right? So here, as we said in my first video, the introduction video for this section, this is considered to be the inside part of the exponential, right? And how do we know that? Because in the exponential function, where do you input? The input here happens here. Input happens here, right? So that's your input. That means that this is, by equivalent, the inside of the function. And therefore, this is the outside function, right? So the important about this is that we're going to have to follow chain rule, and the derivative of the outside, being the exponential, as we mentioned before, is itself. And then because of the chain rule, we said we leave the inside as it is. So let me give you guys an example here. Itself times u prime, right? That's supposed to be a u. It looks like a... All right, there you go. So it's itself, copy and paste the function and multiply by the derivative of the inside, right? So let's finish this up. The derivative of 6 y cubed, well, this is power rule, right? So multiply the 6 with the 3 and subtract 1 from the power. 6 times 3 is 18 times y squared. The derivative of a constant, adding a constant, is 0. So this is where we stop. And so the derivative of this will be 18y cubed times e to the 6y cubed plus 4. It is very common, and sorry, I forgot to put the prime here, prime there. It's very common for us to always put the multiples, the multiples in the front and the exponentials at the end. Exponentials, the end.